Okay, grade 12. Today we start with our normal distribution. You heard a lot said about it, and now you're actually going to learn how to deal with it. Okay, you might have heard it referred to as a bell curve, or you might also have heard it referred to as a Gaussian curve. Okay, and most or many continuous random variables follow this sort of curve, with where the majority of the values cluster around a central point or a mean. Okay, and depending how spread out it is, that will actually give you your mean and your standard deviation. So if we have a look at graph 1 over here, you'll see that your mean is at -1, and our standard deviation is approximately 0.5. If we look at graph 2, our mean there is 0. Can you see it's more spread out? So it's got a larger standard deviation. So our standard deviation there is 1. And if we look at graph 3, our mean there is 3. And you can see that's a really skinny graph. So we have a smaller standard deviation. Standard deviation is all about the spread. So in general, if x is a continuous random variable that follows a normal distribution with a mean of mu and a variance of sigma squared, and you'll recognize this notation, it can be written as x can be approximated by a normal distribution in mu and sigma squared. And don't get a fright, but this is what its probability density function looks like. 1 over sigma times the square root of 2 pi e to the negative half x minus mu over sigma all squared. Now, this is not on your formula sheet, but lucky for you, you don't need to know it off by heart. What you do need to know is to be able to identify where you could read the sigma or the mu off of that formula. Okay, now different properties of our normal distribution. Okay, they're defined by two parameters, our mean and our standard deviation. And the cool thing about this is that the normal distribution is symmetrical about the mean. Okay, also the mean, the median, and the mode are all equal. Okay, and the area under the curve is equal to 1. Okay, we've already discussed that because we know that the area under the curve of a PDF is equal to 1. So our integral from -infinity to +infinity of f of x dx has to equal 1. And the majority of the values cluster around the center of the curve, with fewer values at the tails of the curve. Now, important intervals and their properties. Most of the questions you're going to get are tick active for this section of work, but you need to know these 3 intervals for tick free. Okay, so you need to know these off by heart to be able to do tick free questions. Okay, and that is that approximately 68% of the population falls within 1 standard deviation of the mean. So my mean minus 1 standard deviation and my mean plus 1 standard deviation is going to have approximately 68% of my population. Approximately 95% of my population falls within 2 standard deviations of the mean. So the mean minus 2 sigma and mean plus 2 sigma is 95% of the population. Okay, and the last one that you need to know for those 3 is that 99.7% of our population is going to fall within 3 standard deviations. So mu minus 3 sigma and mu plus 3 sigma. Okay, we say that a randomly chosen member of the population will almost certainly be within 3 standard deviations of the mean. Now we call these facts the empirical rule, or the 68, 95, 99.7 rule, and you have to know this. Okay, and here's just a summary of that, showing that about 34% within 1 standard deviation, 34% will fall below the mean, 34 above, and so on for your various standard deviations. All right, now here they're giving us a probability density function for a normal distribution, and it's that horrible formula. Okay, and they want us to state the mean and the standard deviation and then sketch the function. Okay, so let's use our formula that we have got. So the standard form of it, 1 over sigma root 2 pi e to the negative a half x minus mu over sigma all squared. Now we need to get it into that form. Okay, and you'll notice it isn't quite in that form. So I can rewrite that. Let's rewrite that. We've got 2 over root 2 pi e to the negative a half. It's nearly there. 2x take 1 all squared. I could rewrite that. Let's take that 2 down so that I can get it to be a sigma. So if I take 1 over, I need to then write it as a half. Okay, so I'm taking this 2 underneath my vinculum, and that's going to become a half. Then I have square root of 2 pi, that remains. And then e to the negative a half. And again over here, I need to get my sigma below my vinculum. So I'm going to just rewrite that, and I'm going to rewrite that as x minus 1 over a half squared. And what you'll notice is that my sigma, both cases are the same there, and both cases are a half over there. That tells me that I've rearranged that formula correctly, and now I can just read it off. So therefore, my standard deviation is a half, and my mean is 1. Now, you are not going to have to sketch this without technology. Okay, so using technology, and what it is just a standard normal distribution with a mean of 1 and a standard deviation of 0.5. So what that looks like is something like this. Okay, and we're going to need to go up to 3 standard deviations. So we're going to go negative 0.5, 0.5, 1, 1.5, 2, and 2.5. So that's going to be 0.51, 1.52, 2.5, and negative 0.5. There's 0. And we know that our mean is 1. So we're going to put our dotted line through our mean, and we're going to draw a beautiful bell-shaped curve. Remember that you need to try and get it as symmetrical about the mean as you possibly can, and it looks something like this. And this point up here will be 1 and 2 over root 2 pi.